You open Google Maps, put in Paris and Rome, and ask for directions. The route is on screen straight away. A map like that one has around 18 million intersections, every place where two roads meet. Searching it properly means looking at more than half of them, which takes a computer over 2 seconds on one core. Google Maps is not doing that in every system that publishes how it does this. Most of the map has already been folded away before you ask, and not one real travel time is lost in the folding. Google has never published how Maps does this, so what follows is the technique the system that do publish use. And this is about how the roads get found, not how the traffic on it gets predicted. Suppose you had to find the quickest way here honestly, you would start at your end and step outward. Take the cheapest road you have not taken yet, then the next cheapest, and keep going until you arrive. The shape that search makes is a flood. It spreads in every direction, including backwards, because until you get there, you have no way of knowing which direction was the useful one. On this map, that floods end up looking at 9.3 million intersections, which is more than half of Western Europe for one person going on one trip. That size is a price you would feel. There is a research survey that collects measurements like this, and on the machine it used, that one route took 2.2 seconds. One route, one core. But the first thing anybody tries is to aim. You know roughly where Rome is, so push the search towards it. Let it ignore the roads going the other way and hope those 2 seconds come down. People have measured exactly that. The survey's words for road networks are that the bounds are poor and the performance gain is small or non-existent. A straight line to your destination tells you almost nothing about how long the roads take, and a motorway that swings the wrong way around a mountain still beats a lane pointing straight at it. Aiming barely moves those 2 seconds, so try the other end instead. Start a flood in Paris, start a second one in Rome, and let them grow towards each other. That genuinely helps. It takes the search from 9.3 million intersections down to 4.9 million. So stop searching. The people building this have something you do not, because they know every question before it is asked. Every route anybody could ever want is a pair of points on a map they already hold. So work them all out in advance, store the answers, and look yours up when you ask for it. That survey worked out what that would cost. For this one map, it comes to over a million gigabytes and 6 days of computing to build it. Their own word for that is impractical. It would need more than a petabyte of memory, about 3 million times the size of the map it is answering questions about. So rearranging the search does not get you there, and the answers cannot be stored. That leaves one thing in the picture nobody has touched yet: the map. Go all the way into somewhere unremarkable, a small crossroads on the edge of a town, with one road arriving from a neighbor and one road leaving towards another. Say the way in takes 9 minutes and the way out takes 8. Those two numbers are made up for the sake of one clear example. The map has 18 million of this. Long before you ask for anything, this junction gets taken out of the map. Taking out would break every route that ran through it, so at the same moment, a new road is drawn straight from the first neighbor to the second. That new road is labeled with the time of the journey that used to go through the middle: 9 plus 8, 17 minutes. Anybody driving from the first neighbor to the second still gets told 17 minutes, because 17 minutes is exactly how long it took the old way. This is the simple version of the rule. The new road only gets drawn where the path through the middle really was the only quickest way between those two neighbors. Do that to one junction and nothing much has changed. So it gets done to the next one and the next. It works from the least important roads upward until the whole map has been through it. Picture the dead ends going first, then the residential streets, then the small roads between towns. What is left standing at the end is a skeleton, a thin web of long roads spanning the continent, each one standing in for thousands of small ones underneath. One word needs taking back there though. Nothing was actually taken off the map. The finished map still holds all 18 million intersections, and what each one gained is a rank, a number saying how important it is, and your search may only ever climb to a higher one. So the small streets are still there, your search simply never goes down to them. All of that for the whole of Western Europe takes about 5 minutes on one core, and it happens once for everybody before anyone asks for anything. There is no stored pile of answers in there. The finished thing fits in the same space the plain map needed, under half a gigabyte for the lot. Now ask Maps for that route. From the Paris end, the search only ever climbs off your street onto a bigger road, off that onto a bigger one again, up onto the skeleton. From the Rome end, the same thing happens backwards. Two small climbs from opposite ends, somewhere up in the roads, they run into each other. They do not stop at the first touch, because the first place two searches meet is not always the best one. So both carry on a little longer until nothing better can turn up. When it settles, that search has looked at 200 280 intersections. On the same map where the honest flood had to reach 9.3 million, that is around 3000 times fewer, and it takes 110 millionths of a second, which on that same single core works out at roughly 9000 routes every second. 280 gets you the travel time, and turning that back into street by street directions, unfolding each of those long roads into the small ones it stands for, is a little more work on top. Searching this map honestly means looking at half a continent, and that takes over 2 seconds. So before you ever ask, the small intersections were folded away into single roads carrying the exact time of the path they replaced. And your search runs on what is left from both ends and has the answer after a few hundred intersections. So the next time something on a screen answers faster than it possibly could, the question worth asking is not how fast the machine is, it is what somebody finished before you asked. Alright, if you like the video, make sure you like and subscribe. Thank you for watching.